Okay, we've all been there, right? You're trying to understand this massive, incredibly complex software system, and somebody hands you an architecture diagram that literally looks like a giant bowl of spaghetti. Well, today on The Explainer, we're tackling this notoriously frustrating challenge head-on. We're going to compare C4 modeling with the incredibly rigid IEEE 4210 standards, and, more importantly, we're going to show you exactly how to align the two so your documentation actually makes sense.
But before we dive into the solutions, I really want you to take a second and picture your own team's architecture diagrams. You know exactly the ones I'm talking about. The overcrowded, smudged whiteboard photos, the completely inconsistent shapes and lines just pointing absolutely everywhere. Ask yourself, who actually understands them? Like if a brand new developer or maybe a non-technical business stakeholder looked at your current maps, would they have any idea how your system actually works? Honestly, if your answer is no, you are definitely not alone.
So here is our roadmap for today's explainer. 1. The basics of C4 modeling. 2. IEEE 4010 architecture standards. 3. Aligning C4 with IEEE. 4. Best practices for documentation. And 5. We'll wrap up with a really fun Ghibli art generator example.
All right, let's dive right into Section 1, the basics of C4 modeling.
So what actually is it? Well, the C4 model was created by software architect Simon Brown. C4 stands for context, containers, components, and code. At its core, it's basically just a way to describe software architecture at multiple distinct levels of abstraction. And you know, what makes C4 so incredibly powerful is its sheer emphasis on simplicity and structured hierarchical decomposition. It doesn't force you to learn some complex new modeling language. Instead, it just gives you these clear, layered diagrams that successfully communicate architectural decisions to everyone, from your most technical lead developer all the way to your least technical business stakeholder. It's a real game changer.
Moving right along to Section 2, IEEE 4010 architecture standards.
Now, when we talk about doing architecture strictly by the book, we are talking about the IEEE 4201 standard. This standard dictates some very strict elements that any valid architecture description simply has to have. First up, you have to define your stakeholders. So, who actually needs to know about the system? Is it business, ops, developers? Then you need to address their specific concerns, what matters to them, whether that's security, performance, things like that. Next, you need views, which are the actual diagrams tailored for those specific stakeholders. And finally, models, which break down the structural or behavioral aspects of the system. So yeah, it's rigorous, it's incredibly thorough, but let's be honest, it can also feel a little bit abstract.
Which perfectly sets up Section 3, aligning C4 with IEEE.
This brilliantly illustrates the connection we've been building toward. Those highly formal IEEE elements, they map directly to the C4 approach. C4 diagrams are essentially the exact views that the IEEE standard is demanding. Think about it. The system context level speaks directly to your broad stakeholders. The containers level provides that high-level technical view. The components level is the view strictly for your developers. And the code level, that addresses the models of implementation. So C4 isn't just some trendy drawing style. It is literally an enterprise-grade execution of those rigid IEEE standards.
Notice how every single level of C4 serves a highly specific IEEE stakeholder and their concerns. At level 1, context, the focus is just the system as a black box. This is tailored perfectly for business stakeholders who really only need to see the users and external systems. Move down a step to container, and the audience shifts. Now architects are needing to see web apps and databases. Then component zooms in even further for developers so they can see internal structures like controllers. And finally, code gives those same developers the highly detailed implementation view. It's perfectly mapped. Every single IEEE concern is met with a specific C4 level.
Okay, Section 4, best practices for documentation.
So how do we actually execute this without losing our minds? To keep your C4 models IEEE compliant and, actually useful, here are your rules of thumb. First, keep the diagrams simple. Please do not overcrowd them. Stick to one clear diagram per level. Second, use standard shapes consistently. Simple rectangles usually do the trick perfectly for systems and containers. Third, and this is absolutely crucial, always add text annotations. A box is just a box until you explain it. You need text explaining the tech choices, protocols, or key responsibilities. Fourth, link your diagrams hierarchically, so viewers can seamlessly navigate up and down the abstraction levels. And fifth, if you have super complex interactions, definitely include dynamic sequence diagrams to complement your structural C4 views.
And please, I'm begging you, step away from the overcrowded, messy physical whiteboards.
To build truly maintainable diagrams, look into purpose-built tools. Structurizer is fantastic, created by Simon Brown himself. Plant UML with the C4 plugin is an amazing choice if your team prefers a Dox's code approach. And of course, visual tools like Lucidchart, Draw.io, and Miro are excellent if you want collaborative, clean diagramming.
Finally, Section 5, the Ghibli Art Generator example.
Let's actually see all this theory in action. We're going to use what I like to call the camera zoom metaphor. I want you to imagine you're sitting in a helicopter, looking down at a huge city, and then you slowly zoom your camera lens all the way down to the individual bricks on a single building. We are going to do exactly that right now with a fun system called the Ghibli Art Generator.
So, we start at level 1, the system context. We are zoomed all the way out, high above the city. Up here, our system is entirely a black box. What does the business stakeholder see? Well, they simply see users uploading images via a web or mobile application, they see our system, the Ghibli Art Generator, receiving that user input, and they see it talking to an external system, the OpenAI DALL-E API, to generate the final art. It's a super broad, simplified view, making sure everyone instantly understands what the product does and exactly who interacts with it.
Now let's zoom the camera in a bit closer to level 2, the container diagram. We're finally opening up that black box. The audience here is your architects and your dev leads. Now they can see a web application built in Spring Boot that's handling HTTP requests. They see a service layer making the actual calls out to the AI model. They'll note an optional database for storing user uploads. And they see exactly how we're connecting to the external API using REST. The technical boundaries are just perfectly clear. Zooming in even closer, we hit level 3, components. We are now looking directly at the internal structure of that Spring Boot application, and this is strictly for the developers. They see specific logical units. There's the Ghibli Art controller, which validates the uploaded image. There's the Ghibli Art service handling the business logic, converting the file and pinging OpenAI. And importantly, there's an exception handler sitting right there to manage errors and log details. We are looking at the real mechanics of the system now.
And finally, we zoom all the way down to those individual bricks. Level 4, code. This is exactly how it executes. Step 1, the controller receives the multi-part file. Step 2, the service converts it to a resource. Step 3, it builds the image prompt. Step 4, it calls the OpenAI API client. And Step 5, it returns the generated image bytes. It is precise, it is incredibly detailed, and it perfectly completes our hierarchical decomposition.
Which brings us to our final thought for the day. Ask yourself right now, do your architecture diagrams actually make sense to the people reading them? By combining the rigorous standards of IEEE 4210 with the clean, hierarchical visual language of C4 modeling, you can ensure that your stakeholders, your architects, and your developers all have exactly the view they need. So, here's my challenge to you. Take a hard look at your team's current documentation today. Could you cleanly map it to the 4 levels of C4? Because if not, well, it might just be time for a whiteboard intervention. Thanks so much for learning with me today on The Explainer, and I really hope this sparks some great conversations in your very next